Analytical Geometry Grade 12 Exam Questions November 2020 Paper 2 Question 3 from DBE. Okay, this is the question 3 from November 2020 from DBE. Okay, you have 6 questions to solve and the total is 21 marks. Okay, question 3 from November 2020. Okay, this is the question 3 from November 2020. Okay, so we are going to start with 3.1. 3.1, calculate the gradient of WP, 2 marks. Okay, this is WP. Okay, WP. So this is the equation to find the gradient. The gradient of the line WP is equal to change in the y over change in the x. Okay, change in the y over the change in the x. Okay, you can have 1 and 2. Okay, 1 and 2, or 2 and 1, 2 and 1. I prefer to have it as WP because I'm trying to find the gradient between W and P. So the coordinate of W, you are given the coordinate, and the coordinate of P, you are given. Okay, so you need any 2 points on the line to find the gradient of the line WP. So we are going to use this formula, okay, to find the gradient of the line WP. The gradient of the line WP is equal to, now you have the y coordinate of the point W, the y coordinate of the point W, which is 4. This is the y coordinate, this is the x coordinate. The first coordinate is always x and the second coordinate is always y. Okay, the first coordinate is always x and the second coordinate is always y. So the y coordinate of the point W, this is the y coordinate, it's 4, minus the y coordinate of the point P, the y coordinate of the point P, it's negative 4, okay, over the x coordinate of the point W, the x coordinate of the point W, it's negative 4, minus the x coordinate of the point P. This is the x coordinate of the point P. Okay, the gradient of the line WP is equal to, you are going to have 4 plus 4, which is 8, over negative 4. Okay, negative 4 minus 0, this is negative 4. You are going to have negative 2. Okay, now question 3.2, show that the line WP is perpendicular to the line ST. Okay, if the gradient of the line WP times the gradient of the line ST is equal to negative 1, then the two lines are perpendicular to each other. Okay, if the gradient of this line times the gradient of this line is equal to negative 1, then we know that the two lines are perpendicular. Okay, so the gradient of the line WP, we have it, we calculated it. Okay, so it's negative 2. Now the gradient of the line ST, we can get it. You can see you have the equation of the line ST. Can you see? The equation of the line ST is equal to y equal to 1 over 2x plus 6. This equation is given in the form mx plus c. Okay, so this is the gradient, 1 over 2. Okay, the gradient of the line ST is 1 over 2. So the gradient is obtained from the equation, okay, from y is equal to 1 over 2x plus 6. Okay, from this equation of the line ST, you can see the equation of the line ST. The gradient is 1 over 2. Okay, you can see that. Now we are going to multiply the two gradients. Okay, we are going to multiply the two gradients. So you have negative 2 times 1 over 2. This is equal to, you can see, this is equal to -1. Okay, from this, we can conclude the two lines are perpendicular to each other because the product is equal to -1. So we can say, therefore, WP is perpendicular to ST. Okay, the line WP is perpendicular to the line ST. Okay, now question 3.3. If the equation of SK is given as 5y plus 2x plus 60 is equal to 0, calculate the coordinates of S for max. You can see this is S. You can see S is the point of intersection of the line SK and ST. So we are going to equate the two equations, the equation of the line ST and SK, so that we can find the X and Y coordinate of the point of intersection. Okay, so we are given ST. Okay, we are given ST. So the equation of ST is given. Okay, you have it. Now we need the equation of SK. It's given. So we have to make Y the subject of the formula first. Okay, make Y the subject of the formula first before you can equate the two equations. Okay, so SK is given like this. You are going to make Y the subject of the formula. So 5y is equal to -2x, -60. When you take 2x to the right and 60 to the right, you are going to have 5y is equal to -2x, -60. Okay, now you are going to divide by 5 throughout so that you can have y as the subject of the formula. Okay, you are going to have y is equal to -2 over 5x, -12. Okay, when you divide by 5 throughout. Okay, so this is the equation of SK and this is the equation of ST. So you are going to equate the two equations. Okay, equate the two equations. So you have for ST, okay, ST is equal to, for SK, okay, so this is what you have to do because ST and SK, they have the same X and Y values at this point, okay, at the point S. So this is the reason why you have to equate the two equations. Now you are going to have 1 over 2x. You take this to the left plus 2 over 5x. Okay, this is equal to -12. You take this to the right, -6. Okay, you are going to have 9 over 10. Okay, 9 over 10x is equal to -18. Okay, now you are going to multiply by 10 over 9 on both sides so that you can solve for x. When you multiply by 10 over 9, you are going to have x is equal to, you multiply by 10 over 9, you are going to have -20. So y is equal to, you plug -20 into the equation. In this equation or this equation, I'm going to use this. So you are going to have 1 over 2 times -20 plus 6. Okay, you are going to have this is equal to -4. So these are the coordinates of the point S. Okay, so we are done with question 3.3. Okay, let's move on to question 3.4. Okay, let me get the question again. Question 3 from November 2020. Okay. Now it's question 3.4. Okay. 3.4, calculate the length of WR. Okay, 4 marks. Calculate the length of the line WR. Okay, calculate this length. okay, calculate this length. We are going to use the distance formula. Okay, this is the distance formula. You can find the distance formula on the information sheet. Okay, on the information sheet, you can find the distance formula. Okay, this is the distance formula. Instead of x2 and y2, I've got xw and yw. Okay, instead of x1 and y1, I've got xr and yr. So this is the distance formula that you need to use to find the length WR. Okay, so now you need the coordinates of the point W and the coordinate of the point R. Okay, we have W. Now R, we have the x coordinate. Okay, the x coordinate is -4 because W and R are on the same vertical line. Okay, so they are on the same vertical line. They are going to have the same x coordinate. Okay, -4. The y coordinate, we don't know. Okay, we don't know the y coordinate of R. So we are going to write yr. Okay, we don't know the y coordinate of R. We only know the x coordinate, which is -4. Okay, so let's find the y coordinate of R. When you check on the diagram, you can see that R lies on the line SK. Okay, R lies on the line SK. So the point R lies on the line SK. So you can use this to find the y coordinate of R. Okay, we have the x coordinate of R. So the equation of SK from the previous question, the equation was given as 5y plus 2x plus 60 equal to 0. From question 3.3, the equation of SK was given as 5y plus 2x plus 60 is equal to 0. And after making y the subject of the formula, you are going to have y is equal to this. So we are going to plug -4 into the equation so that we can find the y coordinate. Okay, so you are going to have yr, the y coordinate of R is equal to plug -4 into the equation. You are going to have -2/5 times -4 minus 12. Okay, you are going to have this. Minus 12, this is equal to -52/5. Okay, now you have the y coordinate of point R. So R, the coordinate of R, -4 and -52/5. Now you can use this formula, okay, to find the length WR. This is the distance formula, okay. So WR is equal to plug everything into the formula. You're going to have this, okay. This is the x coordinate of W, okay, the x coordinate of W, -4, minus the x coordinate of R, okay, the x coordinate of R, okay, plus, in bracket, the y coordinate of W, the y coordinate of W, minus the y coordinate of R, okay, this, the y coordinate of R. So WR is equal to, plug this in your calculator. You are going to get the answer. Okay, so this is what I have. You are going to have 72/5. Okay, 72/5. Or you can write your answer like this. Okay, you can see that. Can you see? 72 divided by 5. Okay, 5 goes into 72 14 times. Okay, 5 times 14, it's 70. 72 minus 70, you're going to have 2, okay, over 5. You can give your answer like this or like this. Okay, so I've got an alternative method that you can use to find the answer to question 3.4. Okay, alternative method. Instead of using this method, you can also calculate 3.4 using this method that I'm going to show you. Okay, so the question is calculate the length of WR. So you can see WR. Let me show you. Let me get my highlighter. Let me use yellow. So you need to calculate this length. Okay, WR. Now you can see the length, this distance, WR, the distance or the line is trapped between this line and this line. Between the two lines, okay, you have this WR. So another method, alternative method that you can use, the length WR is trapped between this line and this line. What you can do is to find the equation between the two lines, okay, this line ST and SK, because the line WR is trapped between the two lines, okay. So WR is equal to ST minus SK, okay, top minus bottom. So the equation of the top line minus the equation of the bottom line, okay, top line ST, bottom line SK, okay, because the line WR is trapped between the two lines, okay, you can see that. You're going to do this. So WR is equal to the equation of ST. ST is given, okay, minus the equation of SK. SK, remember the equation of SK is this. Remember from the previous question. Okay, make sure you put inside the bracket because the minus is going to affect everything inside the bracket. WR is equal to 1 over 2x plus 6 plus, okay, this is going to change. Because of minus, you are going to have plus 2 over 5x plus 12, okay, because of minus. So WR is equal to, these are like terms, okay, you are going to have 9 over 10x, okay, plus 18. This is the equation that you can use to find the length of any line between the two lines. Okay, now to find the length of this line, we are going to plug the x value, which is -4. Okay, the x value is -4. You're going to plug -4. So WR is equal to 9 over 10 times x. X is equal to -4. Okay, plus 18. So now WR is equal to, use your calculator, plus 18 you're going to have this, okay, 72 over 5, okay, as we obtained it, okay, 72 over 5. You can also write your answer like this. Okay, now 3.5, calculate the size of theta, 5 marks. You are given this, okay, this is theta. Calculate the size of theta, this angle, okay. You can see the angle theta is created by the line ST and the line SK, okay. The line ST and the line SK, the angle is created. And you also have this triangle. Can you see this triangle? So, if you can find this angle and this angle, theta is equal to this angle plus this angle, okay? Or what you can do is to find all the angles in this triangle. You are going to use the straight line to find theta. Let's try and solve this question. You are going to understand. Okay, so the vertices. Okay, now to find this angle, we are going to use the line SK. Okay, to find this angle, we are going to use the line SK. Okay, so the equation of the line SK is given. You can see this from the previous question. Okay, you can see from the previous question, SK is equal to this. Now you can see the gradient is negative 2 over 5. The equation is given in the form mx plus c. You know from linear function, the gradient of the line SK is equal to the tangent at n. Okay, so n, you have this line SK intersecting the x-axis at n. So the gradient of the line SK is equal to the tangent at n. So the gradient of the line SK is equal to negative 2 over 5. Okay, negative 2 over 5. This is equal to the tangent at n. Okay, so the angle n is equal to arctan of this. Okay, arctan of this. This is equal to, use your calculator. You press shift and then 10. Now you have arctan of this. Okay, this is equal to negative 21.80. Negative 21.80. Okay, a negative angle. This is a negative angle. This is what you have to know about negative angles. Okay, negative angles are measured clockwise. Okay, negative angles are measured clockwise. Let me show you. This is clockwise. Okay, clockwise. So, at n, clockwise, it's going to be like this. At n. Okay. So, it's going to be the angle MNS. Okay, MNS. Clockwise. MNS. This is equal to 21.80 clockwise. Okay, the negative means clockwise. Okay, negative means clockwise. Okay, this is the angle MNS clockwise. At n, clockwise. Okay, negative means clockwise. Just to make sure, this is clockwise, the same way the clock turns, and this is anti-clockwise. in the opposite direction. So after finding this angle, now you can find this angle. This is a straight line. Okay, this is a straight line. After finding this angle, now you can find this angle. Okay, this is equal to, remember, the sum on a straight line is equal to 180. So this angle is equal to 180 minus this. You're going to have 158.2. So the reason you can say supplementary angles or angles on a straight line. Okay, this is the reason for this. Now we have this angle. Now we need the angle at M. We are going to use ST to find the angle at M. We are going to use the line ST. Okay, the equation of the line ST is this. From the previous question, the gradient is 1 over 2. You can see the equation is given in the form mx plus c. So this is m, the gradient, 1 over 2. So the gradient of the line ST is equal to the tangent at m. This is how you can find the angle at m. Okay, the gradient is 1 over 2. This is equal to the tangent of the angle at m. So the angle m is equal to arctan of this. Okay, arctan of this. This is equal to, you press shift and then 10. Now you have 1 over 2. You're going to have 26.57. 26.57. This is a positive angle. Okay, positive angles are measured anti-clockwise. Remember that. Negative angles are measured clockwise. Positive angles are measured anti-clockwise. Okay, this is anti-clockwise. Can you see? Anti-clockwise. So at M, anti-clockwise. At M, anti-clockwise. You're going to do this. Okay, at M. So you're going to have this angle, which is VMW. This angle. VMW. Okay. So VMW, the angle there. VMW. This is equal to 26.57. Okay, anti-clockwise, because this is positive. Anti-clockwise. So this angle. Now we need this angle, which is NMS. Okay, we need this angle inside this triangle. The angle NMS. The angle NMS is equal to this, because these are vertical opposite angles. Okay, vertical opposite angles. This is why they are equal. Okay, so the reason is vertically opposite angles. Okay, so this angle is also equal to this, because these are vertical opposite angles. Now you have this angle and this angle. So theta is equal to this angle plus this angle. Or what you can do is to find all the angles in this triangle. You know the sum of the angles in a triangle is equal to 180. After finding this angle, now you can find theta using the straight line. The sum of the angles on a straight line is equal to 180. Okay, so theta is equal to this angle plus this angle. You're going to have 48.37. Now 3.6, let L be a point in the third quadrant such that SWRL in that order forms a parallelogram. Calculate the area of SWRL, okay, 4 marks. Let L be a point in the third quadrant, okay, so you are given this, okay. Let L be a point in the third quadrant, okay. The first quadrant is always formed by the positive x-axis and the positive y-axis, okay. The first quadrant is always formed by the positive x-axis and the positive y-axis, okay. Remember that the first quadrant is always formed by the positive x-axis and the positive y-axis, okay. So this is the second, and this is the third, and this is the fourth, okay. Remember that you go anti-clockwise, okay, anti-clockwise like this, okay. First, second, third, fourth. So the question says, let L be a point in the third quadrant. In this quadrant, you have to form a parallelogram, okay. So the parallelogram will be SWRL, okay, SWRL. So L will be in the third quadrant, okay, the third quadrant. So SWRL in such a way that you have a parallelogram. So let me try to draw another side. Remember, the opposite sides are equal in length and they are parallel to each other, okay. Let me get a ruler. So we have to draw a parallel line to this side SW, okay. SW, you are going to have SW, R and L, you join to get a parallelogram, okay. So this side, let's measure this side because the opposite side must be equal in length and they must be parallel. So this side is 3.5. Can you see? Can you see? This is 4, this is 3, 3.5, okay. From there, 3.5, okay. So we have to draw another parallel line, okay. So I'm going to have another line starting from there. It must be 3.5, okay. 3.5 like this, okay. 3.5 because this is 3.5. So this and this, they are parallel to each other, okay, because this is a parallelogram, okay. So I can close this. Now I'm going to have L, okay. So this is L. So I'm going to have SWRL, okay. So now this is my parallelogram. Can you see? So now the area of a parallelogram is equal to base times perpendicular height, okay. Base times perpendicular height, okay. So if I use this as a base, the perpendicular height is going to be this, okay. If I use this as a base, the perpendicular height is going to be this, okay. So I can use this as a base, and then this is going to be my perpendicular height. Or I can use this as a base, and this is going to be my perpendicular height. So let's use this because we have WR. We have this length from the previous question, question 3.4. Remember, question 3.4, WR is equal to 72/5. Okay, so let's use this. This is going to be our base, and so this is our perpendicular height. Okay, the perpendicular height. So this is our base, and then this is our perpendicular height because we have WR, our base, from question 3.4. So B is equal to 72/5 from 3.4. Okay, so the perpendicular height is equal to, can you see the perpendicular height is between this line and this line? Okay, between the two lines, from this to this. Okay, so you need your x values. Okay, you need your x values. Okay, so this is -4. Can you see? This is -4. And this is equal to, remember the coordinate of S from the previous question. So x is equal to -20. Okay, so whenever you are trying to find a horizontal distance, you are going to use your x values. If you are trying to find a vertical distance, you are going to use your y values. Okay, so when it is horizontal, you are going to start from the right minus what you have on the left. Okay, from the right, you have -4 minus what you have on the left. Okay, minus what you have on the left. Always, if it is a vertical distance, you are going to take your y values from top minus what you have at the bottom. Okay, remember that. So perpendicular height is equal to -4 plus 20. Okay, so 20 minus 4, which is 16. Okay, so the area is equal to the base. This is the base times perpendicular height, which is 16. This is equal to, use your calculator, 72/5 times 16. So this is equal to 230.4. Okay, 230.4 square units. Okay, another way that you can find the area of this parallelogram, you can first calculate the area of one triangle. After finding the area, you are going to multiply by 2 because you have 2 of them. They are the same. Okay, so we are done with question 3 from November 2020. Okay, until next time, I will talk to you soon.